Hi everyone, and welcome to this lesson on factoring expressions in the form x squared plus bx plus c. These are also known as simple trinomials. So the first thing we're going to start off with today is a little investigation, and this investigation involves us just expanding things. So things we've done before, we're going to use FOIL. I'm going to go over both ways that we can expand. The first one, though, I will do with just going ahead and reminding us that what happens when we multiply one bracket by another bracket is we take the first term and multiply it by both the terms in the second bracket, and then we take the second term and multiply it by both terms in the bracket. So it could look like this: x times x plus 5 plus 2 times x plus 5, and then we would expand it out and we get x squared plus 5x plus 2x plus 10, and then we collect these like terms together and we get x squared plus 7x plus 10. Now that will work always, but what we noticed in our previous lesson is that if we use FOIL, remember that FOIL stands for first, that would give us x times x, which would be x squared. Outside would be the next one, and then that's x times 5 gives me 5x, and then inside 2 times x gives me 2x, and last 2 times 5 gives me 10. And so that would allow me to skip that entire first line that I've written there if I use that FOIL. And so that's what we should be using from now on, and that's what I'm going to use for the other examples. So you might want to pause the video and try these quickly and see if you can FOIL this out properly. All right, so hopefully you've had a chance to do these. I'm going to just put these up quickly here. We get x squared plus 7x plus 1x plus 7, which gives me x squared plus 8x plus 7. The next one, we get x squared plus 6x plus 3x plus 18, and that gives me x squared plus 9x plus 18. So that's what you should have gotten from expanding those. Okay, well, we know how to expand, but remember that the opposite of expanding, going in this direction, is what we call factoring, and that's what we're after in more detail today and in a different way. So taking those questions, let's consider this for a minute. How could we go back to the factored form? Well, let's look at the factors that we have here. Notice that that b and c in the first question represent here the coefficient before the x, and then the last number is c. And so in that first one that we expanded out, we had b to be 7 and c was 10. And we could continue that for the other ones we had. For number 2, we had 8 and 7. And for number 3, we had 9 and 18. Okay, well, we want to also list the factors. Well, what are the factors? The factors are the numbers that are in the brackets. And so in that first case, we had 2 and 5 in the brackets. In the second case, we had 1 and 7 in the brackets. And in the third case, we had 3 and 6 in the brackets. And so what I'm asking you here is, what do those factors have to do with b and c? How do they actually compare? And if you look at these numbers, we can see in this first case that 2 times 5 is equal to c, and 2 plus 5 is equal to b. Same thing in the next one. If I multiply them together, 1 times 7, that's equal to c. And if I add them together, 1 plus 7, that's equal to b. Same thing for the next one. 3 times 6 is 18. That is c. And in the second case, we have 3 plus 6 is equal to 9, which is the b value. And so that's interesting that every single time we take the two factors that are in the two binomials, we notice that when multiplying together, they give us a c term, and when they add together, they give us the b term. So when multiplying, they give us the c term. When added, they give the b term. All right, so let's actually apply this to factoring things, and it's actually going to be simpler than you might think. When factoring x squared plus bx plus c, it can be factored into the product of two binomials. We just showed that the p-value and the q value, if those are the two factors, we can factor anything in x squared plus bx plus c into that, if it's factorable. There's some cases where it's not factorable, as we'll see, but oftentimes it will be factorable. So if we take these numbers as p and q in general, so let's assume one of the factors is p, one of the factors is q, what we can do is we can expand this out. Let's go ahead and expand this. Mathematicians like to use letters to show things in general, but if this is a little confusing to you, don't worry, we're going to get some numbers in here in a minute, but try to follow along with the letters as much as you can. First, x times x is x squared. Outside is x times q, which is q times x. Inside is px. Last is p times q. Okay, now what I'm going to do is I'm simply going to rearrange this. I'm just going to switch the order of these two things. We're allowed to do that because whether you add the one before the other, it doesn't matter here. So x squared plus px plus qx plus pq. And now, as we learned yesterday, we can common factor here. So what I'm going to do is I'm going to take a common factor of x out of the next two terms, just out of those two terms right there. I'm going to write it one other way here. I'm going to write it as x squared plus, because the order of multiplication does not matter, I can write p plus q times x. And what you should see here is that if this is the b value, it's p plus q, it's the addition of the two factors. And if this is the c value, p times q, it's the multiplication of the two factors. And so that's exactly what we found in the investigation previously, but now we've proven this in general. If c is positive, meaning if that last term is positive, then what's going to happen is the two factors will have the same sign, as we'll see that in a minute. If c is negative, the two numbers, the two factors, will have opposite signs. The larger factor will have the sign of the, what do you think? It's the middle term. Rather than memorizing those, let's just see how this works out in a few examples together. So the strategy that we're going to start off with here is we want to find two numbers that will add to b and multiply to c. Add to b and multiply to c. And so how we're going to do that is we're going to write a little t-chart here. We're always going to do this for these types of questions, where we say two numbers that are going to add to something. In this case, they're going to add to 8. That's the b term. There's the b and there's the c in this one. And they're going to multiply to 15. And what we're going to do then is we're going to say, well, what are factors of 15? It's just going to limit our options that we're going to choose. And then we're going to see, well, what's the sum of those? So factors of 15, we have 1 and 15. Clearly don't add to 8, they add to 16. We have 3 and 5. Oh, those add to 8. So then those are the factors we're interested in because those add to 8. And so we're going to be able to go directly to the factored form. We're going to write two sets of brackets. We know the first factor is 3, it's positive 3. The second factor is positive 5. And then we just fill an x in front of those. So x plus 3, x plus 5, and that's factored. You can actually check that. If we expand that, we would get first would equal x squared. X times x would be x squared. Outside, 5x. Inside, 3x. Last, 15. And when we combine those terms in the middle, to simplify it, we get 8x, x squared plus 8x plus 15, exactly where we started. So that's what we've just done. We've just factored that. And then just as a check, I expanded that there. It's always a good idea as you're getting used to it, just to check it by expanding it out. All right, well, what happens if we have negatives? So this next question looks at some negative values. Same thing that we're going to start with. Two numbers that add to negative 3 multiply to negative 54. So the first thing we're going to do is list some factors of negative 54. Now, you might think here, well, factors of negative 54, there are quite a few. Because it adds to something that's so small, those two factors are going to be relatively close together. So we might not need to start at 1 and negative 54, but for the purposes of this question, I'm going to start at some small ones. I might skip a few along the way, but 1 and 54, and you'll notice I made the 54 negative because if it adds to a negative, the bigger factor must be negative. If it adds to a negative, the bigger factor must be negative. So in this case, it added negative 53. We're nowhere near negative 3. I could go 2 and negative 27. Okay, well, that's, again, negative 25, nowhere near negative 3. I'm going to skip a few here. I'm going to skip 3. I'm going to go to 4. 4 times something. Nope, doesn't work. What about 6? 5 doesn't work, obviously, so 6. 6 and negative 9. All right, well, that adds to negative 3. There are your factors. Now, notice one of them is positive and one of them is negative. So we're going to go back and we're going to write this answer. X. We're going to have x's as the first two things. And then in the first case, we'll have plus 6. In the second case, we'll have minus 9. Now, you might be wondering, well, Mr. Hamilton, if I do this, I actually listed the negative first and then the positive. So what I ended up with is x minus 9, x plus 6. Are those the same thing? Absolutely, they're the same thing. The reason they're the same is because the order of multiplication doesn't matter. And so either way you come about that, those are the same answers. So that's all you have to do for that. Again, you could expand that out if you wanted to check it, to make sure that that gives you the same answer, but it should give you x squared plus or minus 3x minus 54. All right, a few more questions here. Let's look at x squared minus 2x plus 1. Two numbers that add to negative 2, multiply to 1. Well, this one's actually kind of nice because it's not very big. Factors of 1. You might be thinking, well, isn't it just 1 times 1? Well, it is, but what's the sum of 1 plus 1? Well, that's 2. Well, I thought it's supposed to add to negative 2. Well, let's make those negative then. Negative 1 and negative 1, those still multiply to 1, but when you add them together, that gives you negative 2. And so those are your factors in this case. And this can be written as x minus 1 times x minus 1, which, if you picked up on this from before when we expanded, this is the same thing as x minus 1 squared. Because anytime you have a factor times itself, you can write it as that single factor squared. The next question here has x squared minus 7x minus 30. Two numbers that add to negative 7, multiply to negative 30. Factors of negative 30. Again, we want the larger factor to be negative because it's adding to negative. So 1 and negative 30 give you a sum of negative 29, nowhere near yet. 2 and negative 15 gives you a sum of negative 13. We're getting closer. What about 3? Well, 3 and negative 10 gives you a sum of negative 7. There you go. There's your factors. So go ahead and we're going to write x and x, and then the first factor is positive 3. The second factor is negative 10. And there's your final answer. Again, you could have written that as x minus 10 times x plus 3. All right, well, this next one looks very similar to that. I'm going to keep the other one up there so we can see that and refer to that. In this case, we're trying to find two numbers that add to negative 7, but before we had multiplying to negative 30, and this time we're going to multiply to 30. And so we're going to have to find two numbers that multiply to positive 30, not negative 30. And let's start listing some factors here. 1, 30, 2, 15, 3, 10, 5, and 6. Those are all factors of 30. If you add any of those up, there's no possible way that they can become a negative number. So none of these are actual factors, and so this is not factorable. You can't make this any simpler than what we have. So try this last one, pause the video, and then come back and see the solution. Two numbers that add to 7, multiply to negative 10. We want factors of negative 10, and we're going to look at the sum of those as well. Factors of negative 10 are 1 and negative, well, we want it to be positive, so I'm going to make negative 1 and positive 10. Gives you 9, negative 2 and 5, and that gives you negative 3. Again, nothing adds to positive 7, so this is not factorable. Please contact me if you have any questions about this video or about the homework. Love to help.